Hello, and welcome to the Keystream Development Kit installation tutorial. With Keystream, you'll embed identity, trust, and control at the heart of your device. In this quick tutorial, we'll guide you through all the steps required to get you started with Keystream. Let's go. The first step is to go on the Kudelski IoT website to get an overview of our solution. You can go under the Kudelski IoT Keystream menu item under Services and Systems. You can click on Get the Dev Kit. From here, you will get step-by-step instructions on how to get a dev kit. You can simply order from one of our distributors. Please check the website for an updated list. The second step is to create an account on Keystream, providing an email and a password. After this point, you will receive an email with a code that you will have to use to validate your address. After the code is validated, you will have to enable multi-factor authentication. You can use Google Authenticator or any other authenticator to do that. Your account is now created and you can log into the system. The first message that you will get is a welcome message and a link to a quick start guide that will describe how you can easily onboard your device, that is, your dev kit, into the system. The first step is to add the device using the claim device that you can retrieve from the application running on the dev kit. You can access all the documentation from the resources section anytime. In the resources section, you will find a link to the documentation's homepage. Under the Key Concepts tab, you have the device onboarding section that describes all the different possibilities to onboard a device. You also get a high-level view of the Keystream portal. You can download the sample application from this page. The sample application contains whatever is needed to compile and run the first example. For instance, I'm now logged in on a Raspberry Pi. I already copied the sample application on this device, and unzipped the application. Inside the application folder, you will find an index.html file. That is the guide that you will have to follow to compile and use the application. How to plug the shield into the Raspberry Pi is also described, but more importantly, it explains what the structure of the folder is, and what you have to do to compile the application. Now let's see how to compile the application. First, you must have some type of hardware, like the Raspberry board we're using in this example, and check the prerequisites list to make sure they are installed. This is something that I have already done on my sample device. I already enabled the wiring Pi and enabled the kernel. After doing that, the next step is to copy some files. What I'm doing now is just following the guide step by step and copying the SAL API requirements in the proper folders. Then I copy the SCL libraries, the SCL required files into the folder. Now that all the requirements are copied, the next step is just to build the application. That can be done by going into the proper folder, so build POSIX. The compilation is quite fast, and what you now get is an executable that is the sample application, called scl_demo_up that is ready to be run. You can configure the sample application's different parameters under the app input folder, by opening the .h file. In this file, you will get all the configuration details regarding the address to which the device must connect, the port, the serial number, the SCL context profile. If you want to customize this file later on because you want to specify some other parameters, you can do it, but it's really not required for the first try. You may leave the file as is. The application is now ready to use and you can start onboarding the device. You can run the application. The application will initialize the SCL. We'll try to connect to the server and, of course, the connection will fail because we did not take any steps to onboard the device into the system. So the very first step is to retrieve the claim token using the first command, so command 1. Let's take the claim token ID and copy-paste it inside the Device Management tab in the Device section. To do that, we just have to go back to the Keystream portal under the App Device tab. As we paste the ID, we'll receive a message saying that the device with ROT public UID is successfully claimed into the system. You will now be able to onboard a device. At the next connection, that is what we are doing now, the device will connect to the backend, and as you can see it will be successfully registered. Our model is now registered and activated. If we check inside the dashboard and inside the device details, we will find information about the number of communications, the type of communication, the number of devices that were connected, their version. And if you look inside the Device Management section, you'll see when it was registered into the system. Under Details, we can see all the low-level details about the root of trust, about the device profile, the serial number. You can also see the device activity, all the interactions that happened between the Keystream portal, the backend, and the device. Now we can start configuring some features on the device directly through the portal. We can do one configuration per device, under Device Configuration. We can select the ROT public UID that we want to configure, and we can do the configuration for all the features that are available at the moment. So there are different authorizations, the configuration of the end-to-end data protection, the loading of opaque data or secret key, the configuration of the connection parameters, or the zero-touch provisioning. For now, just to keep it simple, we only enable the secure channel chip-to-chip feature and local encryption on the device. After we have saved this configuration into the system, we specify that the next time the device connects, those configurations must be loaded. We can see in the device details that the local encryption secret terminal is configured, but not yet in sync because the device actually didn't connect yet. What we'll do now is trigger a connection. We again use the send what's up command number 6. We can see that the what's up was completed successfully. Now we can go back into the Keystream portal and check the feature's configuration status under the device details. As expected, the local encryption is now in sync, as well as the secure channel. We can also access the details of the messages that were exchanged between the device and the Keystream backend. These communications will also appear in the dashboard. What we want to do now is to add information about the device profile. When we want to configure a device profile, we must use the prefix of the device profile that is assigned. Going back into the device configuration panel, I use command number 7 to do the device info ceiling to specify my device profile. I input the correct device profile prefix and a serial number for the device profile. After this step is completed, I will trigger another what's up with command 6, which will complete the seal. We can check in the device management section, under My Devices, that this device actually has the information about the device profile and the serial number. I am now also able to use the device profile I just configured to perform a group configuration for several devices. We can absolutely use the same device profile for multiple devices. In this way, I can simply configure a group of features in one click, affecting multiple devices. For example, you might have 1,000 devices, and want to enable specific features on those located, say, in Europe. You can do that with just one click, and when those devices connect to the system, they will have this configuration loaded. If you want to develop your own application, you can start from the source code of the application and build your business logic around it. You may contact us at any time through our website, or on contact@kudelski-iot.com. Thank you.